Hello, this is Elizabeth Pluswick, and I'm going to do an example here with you from the FE Review Engineering Economics Handbook, the Engineering Economics resource we've been using. And this is example 15.20 from the resource itself, from within the chapter, about incremental analysis. Incremental analysis. This is one that we have not done in class, so I'm talking you through another example from the handout, so you have an additional example to use as a resource. We have two different alternates here. Each one has a 3-year life. This first line shows the initial cost of each alternate. You know, these two alternative solutions are equal in every other way. And so we're just doing incremental analysis to see which one has a higher rate of return. Everything else about them can solves the solution in every acceptable way, meaning it fulfills the same fit, form, and purpose for our problem. We're just doing the financial analysis, saying which one has a higher rate of return. So the costs of the two solutions are different, and the benefits are different from each other. In this example, to keep it a little bit simpler, the benefits for alternative B are the same each and every year for 3 years. And the cash flows in, the benefits from alternative A are the same each and every year for 3 years. So the initial costs are P, present value, and these benefits are both annuities, aren't they? The question is, which alternative should be selected? The company requires a minimum rate of return of 10%. So to solve this, the first thing you do is make a third column and call it increment or difference between the two alternates. Start with a larger cost investment, the larger cost alternate, and then subtract the lower cost investment from it for every year. So 200 minus 131, the difference is $69. Alternative A costs $69 more to buy than alternate B. Then go to line 1, the benefits, 77.6 minus 48.1. A gives a higher benefit of 29.5 for each and every year of the 3 years. So there's the difference column, and that's actually the column that we're going to be doing the analysis on in incremental analysis. What we want to do is set the present worth of the cost equal to the present worth of the benefits, and we're asked to find the rate of return on this set of cash flows. So we're going to find I. We're looking for the interest rate that makes the present worth of the costs equal the present worth of the benefits. And we're just working with this column that's the difference in the cash flows between the two alternates. We don't have to analyze column A and then also analyze column B. We can just analyze the cash flows that are the incremental cash flows, the difference between the two, because alternate A includes all of these cash flows plus more, right? $200 initial cost is the same as alternate B, $131, plus additional $69. Alternate A has $48.1 of benefit each year, plus 29.5 to get to the 77.6. So we just need to analyze the difference between the two, and if that rate of return is higher than if the rate of return on this extra set of cash flows is higher than the company's required rate of return, then we want this extra set of cash flows, right? So that'll be the decision rule. We want to find the rate of return on the difference cash flows and compare it to the company's required rate of return. If the rate of return on this column is higher than the company's desired rate of return, then we want these initial cash flows, these extra cash flows, and they're only present in the higher cost alternate. So then we would choose alternate A. Let's finish solving the problem and then go through the answer and see if it makes sense. Set the present worth of the cost of the difference between the two, $69, equal to the present worth of the benefits, just in the difference column, the incremental column, 29.5. And then you're going to multiply that by a factor to bring these future cash flows back to present day dollars. So 29.5, it's an annuity. It's happening multiple times at equal intervals. So find P given A. We're looking for the interest rate. That's what we don't know. And it's for a 3-year term. So just we want to get that factor to stand on its own so that we can go to the interest tables and find that factor. So this right here is the factor from the interest tables. Some interest table at interest rate I. We're going to find that factor. So just algebraically set that factor on its own. So divide both sides by 29.5. 69 divided by 29.5. That factor equals 2.339. Now your answer here is not the interest rate. Your answer here is this factor from an interest rate table. So you need to go to the interest rate tables and try to find a factor in the PA column, 3-year line, 3-year life, that's equal to 2.339. So let's look. Okay, let's just happen to start with 8%. It's trial and error. You can start with any percent interest rate you want to. PA column, 3-year life, 2.5. Okay, I want 2.3. So let's go down to the 4% interest rate table. 4% PA column, find P given A, 3 years, 2.7. Oh, that's getting a lot closer to what we want because what we calculated is 2.3. So, whoop, that's going the wrong way. We need to go higher, I guess, on this one. PA column, 3 years, 2.1. Okay, that's going the right direction. We calculated 2.3. We're getting closer here to 18% is a 2.17. We're given a 12% interest rate table, 2.4. So our value is just a little bit, very close to the 12% interest rate. We want 2.3. Here I'm finding 2.4, so that's pretty close. So somewhere between 12% and 18%. We could interpolate, usually giving the problems that are on the FE exam are going to give you a calculated amount here that's pretty close to something that they also give you the interest rate table to find. It's very close to 12%. That would be the rate of return on this set of cash flows. Gives a 12% rate of return. Looking back at the problem, the company's minimum required rate of return was 10%. So this cash flow situation gives us a very high rate of return, 12% or higher, even up to 18%. It's in that range. So we want that set of cash flows. So we then would choose the higher cost alternative. We would choose option A. If the factor that you compute here is equivalent to an interest rate that is lower than the company's minimum desired rate of return, then you would not want that extra set of cash flows, and you would choose the lower cost alternative, which does not include those cash flows. Remember, those cash flows are only present in the higher cost alternate. If we didn't like that set of cash flows, it didn't give us a high enough rate of return, then we would choose the option that does not include those cash flows, and that is the lower cost alternate. And that's the strategy for solving incremental analysis, trying to find the rate of return between two different options.